Hi there, remember this one? The Fisher RS-280? Well, I've still got it. I haven't had time to market it properly. I've been busy with school, but now that school's out, it's time to bring out this thing, dust it off, and put it for sale. But before I do that, I need to do a performance verification on it before I put an ad on it. And I want to talk about this unit again because it's a bit unusual. First off, I can't really tell when it's made. It's got some circuit elements that would suggest mid-80s. It has a super cap for preset backup, whereas an older receiver might have either a separate small transformer or perhaps a set of AA batteries. But this one has a super cap. But yet, its amplifier isn't as integrated as other amplifiers would be from the mid to late 80s, so I really can't tell. Part of me wants to say it's from the early 80s, maybe 81 to 82. Well, the other half of me says, oh, 85, 86, but I don't know. I'm kind of leaning somewhere between that 82 and 85 mark. I don't know when it was made. Definitely an 80s unit, though. It's got a 5-band EQ. Of course, it's got a loudness control as well, and you can even defeat the EQ if you want to, which is nice, especially when you want to do a measurement of what its amplifier is capable of doing. The other reason I'm going to measure this amp is to dispel some myths, especially myths surrounding Sanyo Fisher equipment that does not have a silver face. People like to say, never buy one of those, it's a piece of junk. No, I don't think so. I've come across plenty of them that were quite nice, actually. With that said, I mean, I've come across some that aren't very nice, but just the color of the faceplate doesn't mean anything. It's the guts that matter, of course, and in this case, it's pretty darn heavy. This thing's pushing 30 pounds, and as you'll see, it's got some nice abilities to explain the weight. So, they were pretty proud of it, though. 100 watts per channel, continuous RMS into 8 ohms from 20 hertz to 20 kilohertz with no more than 0.05% total harmonic distortion. Let's see if that's true. I've got my Fluke 45 True RMS meter and my Keithley 2015 THD multimeter. Our first test will be at 20 hertz, so it's time to set that up. Okay, so I'm at 20 hertz. I'm going to measure THD plus noise, not just THD. This is a more strenuous test. Almost invariably, I get higher than spec numbers out of this because I'm also measuring the noise instead of just the distortion. But anyway, the 20 hertz is the most stressful for the power supply, so we're going to stress out the power supply first. So for 100 watts into 8 ohms, we want to see 28 volts. So let's crank her up. 28 volts is the goal. We may overshoot it just a hair. Whoops, I have got it in radio mode and not auxiliary. Okay, now we're on the signal generator, and we'll start actually seeing some numbers come across the distortion analyzer. There we go. A little overpower. Let's see here. If I can dial it in here. It's a little tricky. Close enough. It's bouncing around. Yeah, we hit 0.05. But again, that's THD plus noise. I know when we hit 1%. 1% is the onset of audible distortion for most folks. Looks like 30.6 volts. So let's go to the calculator here. And that might blind the screen, but let's see. 30.6 volts squared divide that by 8 ohms. Make sure it doesn't give me a fraction there. 117 watts. So 17% above rated power is available before the onset of seriously audible clipping. And that's pretty good. And that's available on a continuous basis, not just on a burst basis. I don't have the equipment to measure burst power, but I suspect that it's probably in the neighborhood of 140, 150 watts. It's probably got 1.5, 2 dB of dynamic headroom. Okay, so now we're going to measure at 1 kilohertz. So set up the source. 1 kilohertz is the standard frequency that just pretty much every audio gear is measured at. It's really common. Again, 28 volts, and we'll see what it does at 1% THD as well. So looking for 28 volts. Oop. Again, it's a little touchy. Oh, very nice. 0.03. And that's THD plus noise. What do we get at 1%? 31 volts. So that's probably about 120 watts, I would say. Let's see. What does the calculator think? 31 squared divided by 8 ohms. Ow. Give me a fraction. Yep, 120 watts. 120 and an eighth. Again, that's available on a continuous basis. And now, let's do 20 kilohertz. That's the most strenuous when we want to stress out the noise characteristics of something. It's the least stressful on the power supply. But for noise, 20 kilohertz is awful. 20 kilohertz tests are also awful because they can find unstable amplifiers very, very quickly, and usually it results in a big bang when the amplifier blows up due to cross conduction or something horrible. But that won't happen with this unit because I did a good job repairing it. Let's see, again, 28 volts is our goal. 20 kilohertz THD plus noise. Close enough. Oh, wow. 0.02. Fantastic. Let's see what we can get at 1% distortion. Whew, 33 volts. What is that? That's quite a lot of power. Let's see. Divide that by 8 ohms. 136 and an eighth watts. Wow. That's really good. And we're getting all of that from a blackface Fisher. Again, this thing's really, really heavy. This is a beast of a receiver. The amplifier modules, and that's another myth I've just dispelled. People like to rag on equipment that has SDK modules in it. This uses a pair of SDK, I believe it's 01052 modules. And it just did that with SDK modules and a black front panel. So don't judge a receiver by its faceplate or its output modules. Judge it by its performance. And indeed, the performance here is quite stellar. So I hope you've enjoyed this, and I hope you've opened your eyes to other equipment that may be available to you that you haven't thought of before. Anyway, I'm going to go and put this thing for sale. Hopefully somebody will love it. I know I have.